Okay, let's get back to the example. All mammals in this room are humans. Well, let's rewrite that sentence in a different way. For all mammals, if they are in this room, then they are human. This is an equivalent idea, except this time I wrote it with an if-then. So that helps us because it sort of reveals that this is going to be represented by an implication statement, right? If you think about the meaning of these two, they are the same. Saying all mammals in this room are human is like saying, given any mammal, if it is in this room, then it's human. And now we can phrase that in terms of a variable. For all mammals X, if X is in this room, then X is human. All right, so now let's try to convert that into a symbolic statement. For all mammals X, so this is going to be for all X. That is our quantifier, right? And we're going to have to state that the domain is mammals. If, then, right? This whole thing here is going to be an implication. And it says, if X is in this room. Now, that's a predicate, and we defined that predicate in the last video as R of X. Then X is human, that's another predicate, and we define that as H of X. Now, when you do this implication, R of X implies H of X, this whole thing is another predicate. When you combine predicates with operations, you get a new predicate. So this is the predicate, which is being quantified by the quantifier for all X. Okay. So now this is what I've got. So now what I can do is I can say with the domain of mammals, I can and with my predicates as defined, as we already defined in the previous video, I can represent this symbolically by writing for all X. And then I like to put, if my predicate has multiple parts that are combined using operations, I kind of like to put it all inside a pair of square brackets like this. The square brackets don't have any particular meaning other than parentheses. I'm just like lumping them together. For all X, R of X implies H of X. And there we go. So that's how we represent that statement. Now, I want to make a point. And that is that the domain that you are using matters. By the way, I'm terrible at spelling. I don't know why I spell mammals with 2 L's. But the domain that you're using matters, and it changes the way you represent a statement symbolically. For example, if we wanted to use a different domain, let's say the domain is all animals. Well, then we're actually going to need to introduce another predicate, because X now that X could be any animal, X is a mammal is going to need to be a predicate we're going to need to use somehow in order to say all mammals in this room are human, because we don't want to just say the same exact thing. If we say for all X, R of X implies H of X, then that would be saying all animals in this room are human, and now you would be discounting my pet parrot over there or whatever. Or the gecko, you know, or the insects crawling around. Okay, I don't have insects in my room, hopefully. So let's introduce M of X to mean X is a mammal. And now that we have that, we are going to need to introduce that in here somewhere. We're going to have to say this. For all X, not just if X is in this room, but if X is a mammal and X is in this room. Okay, let's take both of those things. If X is a mammal and X is in this room, then X is a human. So I have edited the symbolic statement here to essentially include being a mammal as one of the premises in this statement here, like as part of the hypothesis. We're including it as a premise in the hypothesis. If X is a mammal and it's in this room, then it's human. Okay. So that was my point. Stating what your domain is very important because it changes the symbolic expression that you use to represent a given statement. I think that'll do it for now.